You build and loop in n8n, it runs clean for a while, then one timeout hits. Now, you don't know what already processed, what partially processed, and what never started. So you rerun the whole thing. You create duplicates, or you miss items, and you spend the next hour doing manual cleanup you didn't plan for. The fix is not more nodes. The fix is memory. A place where each run can see what happened last time, claim work safely, and resume from an exact checkpoint without guessing. I'm going to show you a repeatable blueprint using n8n tables as a lightweight state store. This is for workflows that loop, sync, or retry. The goal is simple. Failures become a controlled restart, not a full rerun. Here's the core idea. Your table represents work units. One row per unit of work. One record, one URL, one customer, one file, one sync target. The smallest thing you can safely retry without creating side effects. If you choose the wrong unit, everything downstream gets messy. Too large, and you can't resume midway. Too small, and you drown in overhead. Pick the unit that matches your real-world dependency boundary. The thing you can do twice without harm, as long as you can detect it. Now, the minimum columns. You need a unique key. This is the identifier you dedupe on. It can be an external ID, a composite key, or a stable hash. It must be stable across reruns. If it changes, you lose your guardrail. You need a status. Keep it operational. Pending, in progress, failed, completed, abandoned. You need a checkpoint. This is the last confirmed step that truly succeeded. Not started, confirmed, fetched, transformed, sent, saved. Whatever your workflow actually does. You need an intent count. This is how you prevent infinite retries that look like activity but are just churn. You need last error. Store the message. If you can, store a code. You're not doing postmortems in the execution logs. You're doing them from the ledger. You need timestamps. Updated at, completed at. Updated at is how you detect stuck work. Completed at is how you prove closure. And if you sync in batches, you need a cursor or offset. Something that represents where you are in the source system. Only for batch-style syncs, not for per item loops. That's the schema. The more important part is the contract. How you use it every run. Every run starts by reading state. You never start work blind. If your workflow begins with get all items and immediately starts processing, you've already accepted duplicates as a failure mode. After your read state, you select what to process next. Usually pending. Sometimes failed, but only if attempts remain. Sometimes in progress, but only if it's stale. We'll come back to that. Then you claim the item. this is a write. You set status to in progress. You updated app. You do this before the external call. Pause here, because this is where most duplicate work is born. If you call the external system first and then write state, you have a window where two runs can do the same work. Or one run can crash after the side effect, and the next run repeats it. Claiming first closes that window. After you claim, you do the work, but you don't wait until the end to write progress. After each meaningful step, you write the checkpoint. Meaningful step means one of two things. Either you made an external call, or you performed an irreversible action. If you don't persist after those moments, you will repeat side effects on rerun. So you fetch, you write checkpoint, fetch, you transform. If it's expensive or non-deterministic, you write checkpoint, transform, you send to an API, you write checkpoint sent only after you have confirmed success response. You save it to a database. You write checkpoint saved only after the write is committed. Then you mark completed. And you set completed app. On the error, you write failed. You increment the attempt count. You store the last error. And you keep the checkpoint where it last truly succeeded. That last part matters. If you wipe the checkpoint on failure, you force the next run to redo work you already confirmed. That's how retries become reruns. Now, why does this make retries safe? Because you only retry rows that are failed or rows that are in progress but stale. And you only advance checkpoint when the step truly succeeded. So a retry is not do everything again. A retry is continue from the last confirmed point. And this is how duplicates get prevented. The unique key plus a terminal completed status becomes your independency guard. If it's completed, you skip it. No matter how many times the workflow reruns, no matter who triggered it, no matter what failed elsewhere. If you want a quick test of whether your workflow is designed for operations, ask one question. If it crashes right now, can you restart it without thinking? If the answer is, it depends, you need state. In the next part, I'm going to map this into a repeatable run flow. So instead of rerunning everything, you always restart from a known checkpoint with controlled retries. Let's apply it to three common situations. The loop case is the simplest. At the start of the run, you query rows where status is pending. You can limit the batch size if you want predictable runtime. For each row, you claim it by setting in progress. Then you do the work. After each external call, you update the checkpoint. When it's done, you mark completed. If the run dies halfway though, you don't care. The table tells you exactly which rows are completed, which are failed, and which were in progress when the lights went out. Now, the retry case. When something fails, you do not immediately shove it back into pending. You leave it as failed. You increment the attempt count. You store the last error. You keep the checkpoint. And on the next run, you query failed runs where attempt count is below your max. That max is a policy decision. It depends on costs, rate limits, and how often failures are transient versus structural. If you want the ability to pause retries without editing notes, this is the cleanest control. Failed stays failed until you intentionally retry it. There's also a common failure mode with in progress. A run claims items, then crashes, and those rows sit in progress forever. So you need a stale rule. If in progress is older than, say, X minutes, you treat it as timed out. You move it to failed. You write in timeout error. Now, it re-enters the retry path with full visibility. Now, the sync case. This is where people lose data quietly. If you're pulling from a source in batches, you store a cursor. At run start, you read the cursor. You fetch a batch after that cursor. You process the batch, and you only update the cursor after the entire batch is fully successful. Slow down here, because this is the difference between at least once and maybe never. If you update the cursor before the batch is fully processed, and then you fail, you will skip data. You won't see it again. You'll think the sync is healthy because it keeps moving, but it's silently incomplete. If the batch fails, you keep the old cursor. You retry the same batch. That may reprocess some items, so you'll still need your per item independency, but you will not skip. Now, the operational benefit you get immediately is observability. The table becomes your ledger. You can answer what's pending without opening the workload. You can answer, where did it stop? By looking at the checkpoint and updated app. You can answer, why is it failing? By sorting by last error. You stop doing log archaeology. To keep things from getting stuck, you need terminal states. Completed is terminal. Abandoned is terminal. Abandoned is what you use when max attempts is exceeded or when the error is structural and you decided it needs human intervention. And every error path must write state, no exceptions. If an error happens and you don't write failed with context, you've created a blind spot that will cost you later. Once you've built this once, treat it as a reusable block. Same schema, same read, claim, checkpoint, finalize behavior. Drop it into any workload that needs memory across runs. That's how you stop redesigning reliability every time you automate a new system. If you're dealing with this right now, tell me which problem is costing you the most time in n8n. Loops that duplicate work? Retries that spiral? Or syncs that can't resume cleanly? Comment 1, 2, or 3, and what you're syncing or processing. The blueprint is straightforward. One table row per unit of work. A clear status and checkpoint. Writes immediately after claiming and immediately after each external call or irreversible action. With that, loops resume instead of rerun. Retries target only failures. And syncs continue from the last known good cursor. The mindset is simple. Don't rely on the execution to remember. Persist progress in a dedicated state table. Then, reruns become controlled restarts. Retries become safe and bounded. and long-running syncs become resumable by design.